All right, page 141. Now we are on to numbers 2, text 2.py. Numbers 2, text 2.py. And it's going to be this program converts a sequence of Unicode numbers into a string of text. Efficient version using a list accumulator. Numbers 2, text 2.py. All right, here we go. So, main print. This program converts a sequence of Unicode numbers into a string of text that it represents. The message to encode loop through each substring. And build Unicode message. All right. This is going to be a blank list, or an empty list rather, for stir in string.split. We're going to split them at the breaks, at the natural breaks. Eval come over here, and that'll be a convert digits to number. And append chr and then code num. Accumulate new character. Message. Dot join. Cars. And then print. The decoded message is, and then message. And then invoke the main function. Let's check out how it works. Numbers 2 text 2.py. All right. Let's do the same one as before. 83, 116. We're going back to page 138. 114, 105, 110, 103, 115, 32, 97, 114, 101, 32, 70, 117, 110, 33. Oh, so, oh, well, I missed something clearly. So in string, no, yeah, what did I miss? All right, let's look at it again. Print in string input. It's assigned eval. Oh, what did I mess up on that for? Hello. So that's definitely, yeah, that's not dot notation. That's a function, and then the numster is the argument of the function eval, which is within the loop, the for loop, which is within the main function. I believe that I'm referring to it correctly. Okay, let's see if this works now. Okay, let's just practice. Oh, wow. Hello. So that didn't work, huh? All right, let's keep trying. There we go. All right, let's really try to make it work the same way as page 138. Okay. So let's try 83, 116, 114, 105, 110, 103, 115, 32, 97, 114, 101, 32, 70, 117, 110, 33. There it is. Strings are fun. And let's check out this code again. Okay, so let's just walk through it. So in string is just the input. It's just going to be a block of numbers separated by single spaces, by a blank space. Cars is like basically characters, and it's going to be an empty list, right? So a new list named character cars, and then for numster and string, we're going to split them, and then we don't need an argument inside these parameters because this function, or this method rather, split, doesn't need an argument if they're gonna be split during the natural splits of the single spaces or of a space. I don't know if that's like native to Python only or if that's other languages, like Python, like Ruby, C++, C# and all that. So then now we're in our loop. So code num gets eval of num string. So basically it's going to be, the digits are evaluated to number, right, which are evaluated. the eval function makes them integer, I believe. And then, where is it? I was thinking that eval was a I thought it was a string. Okay, let's just look it up. So eval Python. I thought it automatically evaluated to string. Yeah, normal string, a byte string, or an ASD object. Okay, cool. So eval. Oh, it just evaluates. It just evaluates. So it can be math, it can be, it's just evaluated. Okay. I'm going to learn more about this, I'm sure of it. But for right now, okay. It evaluates it, converts the digits to a number, and then we're going to append the character version of codenum into each place of cars of the list, right? Starting from index 0. And then messages join cars. And we're not going to have any spaces. Why? Because the Unicode message that we're typing, those numbers, they include blank spaces. They include, they include the blank spaces where they belong. The strings are fun. That includes every character within the quotes, which includes the blank spaces. So, and then this here means we're going to return a line, and then, so it's like a carriage return, and then it's going to say the decoded message is, then a space, then the message, which is strings are fun, exclamation point. All right, so now let's look at 5.7, from encoding to encryption on 141, 5.8, I/O, input-output as string manipulation, 5.81, example application date conversion. Okay, so here's our algorithm. And then here are the first 2 lines. Directly encode. Well, let's go over some quick examples just because I want to review. Let's close this up and we'll go here to idle. And sometimes if I'm confused or if it's not super illuminating or it's too general and I feel like I'm not picking it up as much, I work a lot better with examples. I think, yeah, I don't know, that's just, so if something's like too dry, I can get it, but it's just not my preferred mode of learning. I love examples. I love being able to like figure out the story, of how to remember it, how to file it into my brain and remember it. So, okay. And I mean, everyone, has their own shtick, right? Okay, so int of 3 is 3. That's the int. The float of 3 is 3.0. The float of 3.5 is 3.5. Int 3.5. Oh. The string passed to these conversion functions must be a numeric literal of the appropriate form. So it's an invalid literal for int with the base 10, 3.5. So it can be an int of 3 and it can be an int of 3.0. But it can't be an int of the string 3.0. Like, I guess the best way for me to understand this, to try to remember it, is that when you're doing the int version of, the value that's in the parentheses can't leap twice can't leap. It can leap once each time. It can leap from, string to just straight to the int, right? Just gets rid of the quotations and goes to the int. The float, it truncates the decimal and everything past it, so it just, it makes it an int. But it can't leap twice. The quotes and then the point. I mean, it's a double leap. So that's how I would remember it personally. All right. So then let's try this. Let's try int 008. Okay, so a string. That's an integer string. You can make that leap, right? From integer string to just integer, right? Cut out the string. So int 05 should have the same issue, or the same result. It should be a 5, just a straight 5. And then int 009. Oh, and then here, the eval. All right, so here we go. So this is an invalid token. So the eval. Okay, let's go over. We're learning a little bit about eval here. So it's decently clear on it. I probably should be a lot more clear. I'm sure if I was sitting in Professor Zelle's class or someone who was teaching this, I would have known that for sure. Because I mean, already on page 145, and I feel like I'm pretty good at eval. It seems pretty generic in terms of like evaluating it as whatever the value is as a string, like the input sort of, actually, it all depends, right? It means evaluates, I believe, which I just looked up, but it was a little bit dry. So okay, let's just go over this. So in general, then on page 145, if you're converting something that's supposed to be an int, it's safest to use int rather than eval. Okay, cool. That makes sense, right? You want to be as direct as you can and not use some of this kind of generic. Eval seems a little bit generic. We've been using it, but we're turning to the date conversion algorithm. We can turn month str into a number using int, and yada, yada, yada. Okay, so then date convert.py. All right, so we're going to do date convert.py right after this.